Hi everyone, and welcome to Calc Lesson number 56. Today we are going to be looking at U substitution with trig. So let's start with a quick warm-up to get our brains remembering what we've been working on over the last couple of days, starting with integrating using pattern recognition. In number 1, we want to integrate x times the quantity 1 minus 3x squared all to the 4th power dx. When using pattern recognition, we're going to look for that composite function and identify the inside piece. So I'm going to choose this inside 1 minus 3x squared as my inside g of x, which makes my g prime of x equal to, well, the derivative of 1 is nothing, and then the derivative of negative 3x squared would be negative 6x. Checking in on what's left over in my equation, I have the x, but I don't have the negative 6. So in order to compensate for that in my final answer, I'm going to need to have a negative 1/6 on the outside so that my 6 would have canceled. Once I account for my g and g prime, I can go ahead and integrate my outside function as normal. So my outside function would be this something to the 4th power. So when we integrate something to the 4th power, we get something to the 5th power over 5, and then that something is that g of x, that inside function, stays the same, so we keep that 1 minus 3x squared. And then simplifying for our final answer, I'm just going to multiply this 6 and this 5, so I get a negative 1 over 30 times the quantity 1 minus 3x squared to the 5th power, and then of course plus c. So that was over the beginning of this chapter. We were looking at pattern recognition. We also talked about U substitution. So in number 2, if we wanted to integrate 6x cubed times the square root of 3x to the 4th plus 2 dx, remember you would start by choosing your U, and you're going to choose U by looking for the inside function of the more complicated piece. So I'm going to choose U as 3x to the 4th plus 2. So then when I go ahead and find du, taking my derivative, I get 12x cubed. There is no, or plus 2 derivative goes to 0, so this is just dx. Solving for dx then, we would get dx is equal to du over 12x cubed. So now I'm going to rewrite my integral using u and du. So I have the integral of this 6x cubed is going to stay, at least for right now, times, now I want to write the square root of u, but I'm going to write it as u to the 1/2 power times du over 12x cubed. When I do this, I notice that my x cubes are going to cancel, and then I'm just left with 6 over 12, which I can write as 1/2. So I'm going to pull that 1/2 to the outside, and I am just integrating u to the 1/2 du. Now I can just integrate as normal, so I keep my 1/2. U goes to the 1 higher power, which would be 3/2 divided by 3/2. So this would be 1/2 divided by 3/2 is just multiply by 2/3. Those are going to cancel. So I'm left with 1/3 u to the 3/2. And then remember, at the very end, we want to make sure to plug back in for u to give our answer in terms of x. So this is equal to 1/3 3x to the 4th plus 2 to the 3/2 power, and then a general solution, so plus c. So a quick reminder, a quick warm-up of the 2 methods that we were looking at last week, pattern recognition and U substitution. So today we're going to start using both of these methods, pattern recognition and U substitution, as we integrate trig functions. So recall that you have these 6 trig antiderivatives listed on your formula sheet, which is probably somewhere convenient in class notebook. They're also listed on the handout if you decided to print it, or they are right here. So if you need to take a screenshot of this or a picture or write these down, please go ahead and do so, as these are going to be really important through the next couple of problems. So when we are integrating trig functions, we can use either pattern recognition or U substitution. Typically, U substitution tends to be a lot easier as the problems get more complex, but we're going to go through examples of both so you can make that decision on your own. So let's start with a couple of examples using pattern recognition. Starting with number 3, we want to integrate 3 times sine of 3x dx. So using pattern recognition, we're going to look for our inside function, which in this case we can see is 3x. So I'm going to label for myself that g of x equals 3x, which means that g prime of x equals 3. Checking that it's in my integral, 3 is accounted for. So pattern recognition says since we have f of g of x and g prime, we can go ahead and just integrate our outside function, our f. So integrating sine, using that slide from before, the picture we just took, the antiderivative of sine of x is just negative cosine of that same thing on the inside. In this case, it's not just x, it's going to be that whole 3x. So the antiderivative of 3 sine of 3x dx is just going to be equal to negative cosine of 3x, and then of course plus c. So your most basic example with pattern recognition when g prime is already accounted for. If we look at number 4, it's very similar. Here we're taking the antiderivative of cosine of 4x dx. Let's start by choosing our inside function as our g of x. So g of x here is equal to 4x, which makes g prime of x equals to 4, which is not accounted in our integral. So in order to counteract that 4, to cancel out that 4, our answer is going to need a 1/4 on the outside. Then we can go ahead and integrate the cosine function as normal. So cosine, the antiderivative of cosine is just sine of the same thing. So this would be times sine of our g of x function, which is 4x. So we can write our antiderivative as 1/4 sine of 4x plus c. So a quick recap of pattern recognition using trig functions. So let's take a problem and let's do it actually both ways. Let's do it using pattern recognition, and then let's do it again using u substitution and kind of see which one is a little bit easier. So the problem we're going to be integrating here is cosine squared of x times sine of x dx. Now for both of these, before I even get started, I'm actually going to rewrite this as cosine of x squared times sine of x dx. So now using pattern recognition, I'm going to identify my inside function, my g of x, as cosine of x. Now if g of x is cosine, then g prime of x, the derivative of cosine, is negative sine of x. So we have the sine of x, we just need to account for a negative. And now we've accounted for our whole g prime. So now we can go ahead and integrate as normal. We're going to integrate that outside function, which in this case would be something squared. So to integrate something squared, we would get something cubed over 3, and that something is our g of x that stays the same. So we can write our final answer here as negative 1/3 cosine cubed of x plus c. So now let's look at the same problem, but this time using u substitution. So I'm going to rewrite just like I did before, cosine of x squared times sine of x dx. Now when we go to identify our u, again we're looking for that inside of the more complicated piece. So I'm going to let our u equal cosine of x, which means that du, the derivative of cosine, would be negative sine of x dx. So solving for dx, we get dx is equal to du over negative sine of x. So when we go to rewrite our integral, we have the integral of replacing cosine with u squared times sine of x times replacing dx with du over negative sine of x. It's pretty clear that our sine of x's are going to cancel and we're just left with that negative. So this is just the negative integral of u squared du, which gives us negative u cubed over 3. And then replacing back with what we defined as u, we can write this as negative cosine cubed of x over 3 plus c, which is of course the same thing that we got when we used pattern recognition. So two methods, they do the same thing essentially. Pattern recognition is awesome if you can see it and you can visualize it in your head. U substitution is more like a formula that will work all of the time. So identify your U, find what du is, and then continue on just like we always would. However, now we're going to look at it involving trig functions. So we have just a couple of examples to go through today, starting with the integral of cosecant squared of x over 2 dx. So using u substitution, I'm going to choose my u as being the inside of this complicated function. So I'm going to let u equal x over 2, which is the same thing as 1/2 x. So that means that du would just be equal to 1/2 dx. So solving for dx, we get dx equals 2 du. So now we can take our u and our du and we can plug in to our integral to replace. So we have the integral of cosecant squared of x over 2, which is now just u, replacing dx with 2 du. This is the same. We can take this constant and pull it out to the front. This is the same as 2 times the integral of cosecant squared of u du. Using our formula sheet or the front side of this handout, the integral of cosecant squared is just negative cotangent of that same inside, so of u. So this is just equal to negative 2 times cotangent of, replace our u with that x over 2, plus c. Okay, in number 8, we have t's instead of x's, but we can do it exactly the same way. Here we're going to integrate t times sine of t squared dt. So let's go ahead and identify the inside of our complex function. So let's call our u equal to t squared, which makes our du equal to 2t dt. This time solving for dt, we get dt is equal to du over 2t. Now that we've identified each of those pieces, we can go ahead and rewrite our integral, keeping our original t. Now we have the sine of u, and then replacing dt with du over 2t. The t's cancel, just leaving us with this 2 in our denominator, so I'm going to rewrite this as 1/2 times the integral of sine of u du. Using the page of the formula sheet, we know that the integral of sine is just negative cosine, so our 1/2 stays. Integrating sine, we get negative cosine of the same inside, which in this case is u. And then in our final step, replacing our u with that t squared, we get 1/2. Oops, I'm going to pull my negative out front, so negative 1/2 cosine of t squared plus c. So the only additional step here that we're taking with u substitution is now that we have to use those antiderivatives of trig functions. Otherwise, it's pretty much the same as what you were doing over the past couple of days. For number 9, we want to integrate the square root of tangent of x times secant squared of x dx. Now you guys have been in calc class long enough to know that when you have a square root, you should rewrite it using an exponent. So let's start by rewriting this as the integral of tangent of x to the 1/2 power times secant squared of x dx. Now when we're choosing our u, we want to choose the inside part of the more complicated function. So we have a squared and a 1/2 power. Hopefully you guys agree that that 1/2 or that square root is a little bit more complex. So let's choose our tangent of x as being u. And that lets du equal the derivative of tangent is secant squared of x dx. So if we solve for dx, we get dx equals du over secant squared of x. So as we start to rewrite, we have the integral of replacing our tangent with u to the 1/2 power times secant squared of x times replacing dx with du over secant squared of x. Luckily, our secant squared of x and our secant squared of x cancel out, which is really nice. So now we are just left with the integral of u to the 1/2 du, so we can integrate as normal. We're going to take u to the 1 higher power, which would be 3/2, and then divide by 3/2, or just multiply by our reciprocal 2/3. And then, as always, our final step is going to be to replace that u with that original tangent of x. So we can write this as 2/3 times tangent of x to the 3/2 power plus c. Okay, number 10 is our last and most exciting problem of the day. We want to take the integral of sine squared of 3x times cosine of 3x dx. Just like in the last problem, I'm going to start by rewriting this so that the exponent is on the outside. So let's write this as the integral of, I'm going to use a larger bracket here, sine of 3x squared times cosine of 3x dx. Now that I've rewritten it, I'm looking for my most complicated piece, which is going to be that sine of 3x squared. Choosing the inside as my u, that gives me u equals sine of 3x. Now when I go to take the derivative and I want to find du, I have to be really careful to use the chain rule to take this derivative. So the derivative of sine of 3x, you take the derivative of the outside, so the derivative of sine would be cosine, keeping our inside the same, and then multiply by the derivative of the inside, which would be 3 dx. So take a second, make sure you understand why we use the chain rule there. And then just like always, let's go ahead and solve for dx. So we get dx equals du over 3 cosine of 3x. So now we can go ahead and rewrite our integral. So replacing our sine of 3x with u, we get u squared times cosine of 3x, and then replacing dx with du over 3 cosine of 3x. Our cosine of 3x cancels with cosine of 3x, and we're just left with that 3 in the denominator. I'm going to pull that 3 out front. So this becomes 1/3 times the integral of u squared du. And now I can integrate this as normally. So this gives me 1/3. Integrating u squared, I get u cubed over 3. So I can write my final answer back in terms of sine. Sorry about my dog. Back in terms of sine as 1/9 times sine cubed of 3x plus c. I'm so sorry about that. If you have any questions about this problem, feel free to ask your teacher. Great job with this lesson. Homework 56 is on page 301. You're going to do numbers 33, 35, 37, and 39.